Trigonometry is a very big chapter, but in this video, we are going to focus on the following topics: trigonometry of triangles, proving identities, reduction, and solving trigonometric equations. So now, one person might ask, what are you talking about trigonometry of triangles? So basically, trigonometry is the study of right angle triangles. Let's say, for example, if we have a right angle triangle, we have three sides. And then now these three sides, we can relate them by what we call now trig ratios. And then we use a tool that is called SOHCAHTOA to help us actually relate the sides of a right angle triangle. So if we were to name the sides of a right angle triangle, the side that is always looking at 90 degrees, it is going to be the hypotenuse side. But now for us to be able to label other sides, we need a reference angle. So let's assume that our reference angle is going to be this one here. So this side that is looking at the reference angle, it is going to be the opposite side because it is opposite the reference angle. And then the side that is next to the angle, it will be the adjacent side since it is next to the angle. So do you see now, if we were looking for a ratio of sin theta, we're going to say now sin theta is equivalent to opposite over hypotenuse. So looking at this right angle triangle, we can say now, okay, if we had this length of the opposite side, we're going to substitute it, and the length of the hypotenuse side, we're going to substitute it and get the ratio of sin theta. So now you should pay attention to that. These two other sides, except the hypotenuse side, they depend on where the reference angle is. Let's assume that the reference angle was beta here. So now do you see now this side here, it is now opposite the reference angle, so it will have to now be the opposite side. And then this one here will be next to the reference angle, so it is now having to be an adjacent side. So now let's say now they wanted a ratio of cos, but using the reference angle as beta. So you will say now, okay, cos of what? Cos of beta is equivalent to what? Adjacent over hypotenuse. But now you're going to use this side as your adjacent. This is adjacent to the reference angle. And then also you're going to use the hypotenuse side, which is always opposite 90 degrees. So that is a introduction or maybe a revision of trigonometric ratios. So now you're going to be given a question to say now, let's say you have cos of 15 degrees being equivalent to P over 3. So now the question will be saying now, okay, can you determine the following: sine of 15 degrees, and also can you determine cos of 75 degrees in terms of P? So how can you determine the following from this that is given to you? So you need to be able to represent this as a triangle, because now remember the ratios of trigonometry, they come from a right angle triangle. So we're going to say now, if we had a right angle triangle and then our reference angle, which is 15, if we put it here, we know that we're going to have this is our hypotenuse side, this is the opposite side, and this is an adjacent side. But in this case, we are given cos of theta. So if we use SOHCAHTOA, we know that a cos is actually adjacent over hypotenuse. So this means on our triangle, we will represent the adjacent side as P. So now what is adjacent to the angle? Adjacent side is this side here that is next to. So that is going to be P. And then the hypotenuse side, we're going to represent it as 3. Remember, the hypotenuse, it is always looking at 90 degrees. So you see now from this statement that was given to us, we were able to write that information in a right angle triangle. That is the first step for us to solve the following problems. So now, the next step, it will be for you to fully define this right angle triangle. For example, by finding this other side here. So let's assume now this side, we're just going to name it y, but we must find it in terms of p, since we are solving everything in terms of p. So in a right angle triangle, we use theorem of Pythagoras to find the other side if we are given two other sides. So now we are given the hypotenuse side, which is represented by r, that is going to be 3 squared. And then the other side is p, so that's going to be p squared. And then we have a y squared, which we are looking for. So now 3 squared is just going to give us 9. And then when you transpose the p squared on the other side, it's going to be minus p squared. And we have this being equated to y squared. So if you apply the square root on both sides, remember every time when you apply the square root, the answer that you get is plus or minus. So now the value of y is going to be what? Remember now in a triangle, you have now the length. So the length cannot be a negative length. So that means now the answer that you get in this case is just going to be a positive 9 minus p squared. So that will be the value of the other side. So now you have to replace the y with the value that we have found, which is now what? A 9 minus p squared. So this does not mean now we have fully defined our triangle, because now we can still be able to determine what is the value of this angle. So remember now, all the angles inside a triangle are supplementary. So if we have 90 and 15, how much do we need to get 180 degrees? So we can just basically say 90 minus 15, and that's going to give us an angle of what? Of 75 degrees. So now we have a fully defined triangle from this information that was given to us on the problem. After that, we will be able to answer any question. So now the question is that we should find now a sine of 15 degrees. So remember, we know that sine from SOHCAHTOA, it is always opposite over hypotenuse. But look at this, the reference angle is 15. So we're going to look at the reference angle. We say now what is opposite the reference angle is going to be this side here. And then the hypotenuse side is just going to be always 3. So for us to determine this sine of 15 degrees, we're going to say now, okay, the length of the opposite side is just going to be what? Square root of 9 minus p squared. And the length of the hypotenuse side is just going to be 3. And therefore, that is the answer that we will give to the ratio of sine 15 in terms of p. After we have done this, we can also answer this equation of a cos 75. So, but now if you look at cos of 75, if we are looking at cos, the ratio of cos is always adjacent over hypotenuse from SOHCAHTOA. But now, we need to note that the reference angle, it is now 75 degrees. So what is going to be our adjacent side to the reference angle? Our adjacent side is going to be this side here, next to the reference angle. And then the hypotenuse side, it is always 3. So do you see now, cos of 75 degrees is saving the same value as a sine of 15 degrees. So now that is going to be what? Adjacent is 9 minus p squared, all divided by the hypotenuse, which is now 3. So remember, the reference angle, it is what is important, and then we can determine which side is hypotenuse, which side is opposite, based to where the reference angle is. So that is how we will use this trigonometry of triangles. I'm going to do one more problem after we have explained all these different topics. So now, the second thing that we need to understand, or the second topic we're going to look at, it is what we call identities. So we have identities like if we have tangent of theta, we can write it as what? As sin of theta over cosine of theta. So this means tangent of theta, it is identical to sin of theta over cos of theta. So if we had sin of theta over cos of theta, we can decide to change it and write it as tangent of theta because they are identical, they are the same. Those are identities. One other identity that we know of, it is if we have now cos squared theta plus sin squared theta equivalent to 1. This is also an identity. So if you have cos squared plus sin squared, that is equivalent to 1. You don't have to worry about where this comes from, but you just need to know this is an identity. Okay, so now from this identity, we can create other identities. Look at this. So now if you make cos squared a subject of the formula, you're going to have 1 minus sin squared theta. So you see now you have now a new identity that is created from this first identity. So if you have cos squared theta, you can represent it as 1 minus sin squared theta. And then also if you have 1 minus sin squared theta, you can represent it as cos squared theta. The last thing that you can do, you can also make a sin of squared theta to be the subject of the formula, and the same thing will happen whereby you can represent sin squared as what? As 1 minus cos squared theta. So now when you transpose, this is what you get. Okay, so these are normal identities that we have done in grade 11. We should be familiar with these identities. So when you're doing grade 12, you're going to be introduced to what we call now the compound angles, which will lead us to what we call the double angles. So if we have a compound angle of cos, we can say now we have cos of what? Cos of A plus B. So now for the identity of a compound angle, if we have cos, we just have to write it as what? As cos the first angle and cos the second angle, but we have to change the sign in between the angles. If it was positive, it will become negative. If it was negative, it will become positive. And then we now write sine of what? A and sine of B. So that is what we call now the compound angle of cos. So from this compound angle of cos, what will happen if ever now the angles that we have inside are the same? For example, if we now have cos of A plus cos of A. Do you see now this same compound angle is going to now change and become what? Cos of A and multiplied by cos of A minus sine of A multiplied by sine of A. Because now the angles are the same, this will simplify to become cos squared A minus sin squared A. And therefore, this is an identity which we call now a double angle. So that means now for a double angle of cos, if we have now cos of 2A, because now inside here we have A plus A, we can write it as 2A. We will know that this is identical to what we call now cos squared A minus sin squared A. So that is a double angle of what? Of a cosine. So now, from this double angle of a cosine, we can also play around with it. For example, we know that we have this double angle being what? Cos squared A minus sin squared A. So from these identities of number 2, remember we can change a cos squared theta and write it as 1 minus sin squared theta. So if we do that to this identity, for example, we replace now the cos squared as what? As 1 minus sin squared theta. Look at what is going to happen. You're going to say now we have 1 minus sin squared A minus sin squared A. So this will just simplify to be what? Minus sin squared minus sin squared. That's going to be what? A minus 2 sin squared A. So now this is also one type of an identity of a double angle of cos. So that means now this is also the same thing as what? As 1 minus 2 sine squared A. And then we can also do the very same thing now where we replace now the cosine of theta as what? As this identity here. Remember now cos squared of theta, we can also write it as what? We can also write it as what? As 1 minus cos squared A. So when you put the negative, remember now it is very much important to put the bracket because when you minus both the terms. So if we simplify this, you're going to get cos squared A. And then if you say negative by 1, that's negative 1. Negative by negative cos squared theta, that is going to be positive cos squared A. So now what do we have here? We have cos squared plus cos squared, which is going to give us 2 cos squared A minus 1. So this is also another identity of the double angle of cos. So if we have a double angle of cos, we can also write it as what? As 2 cos squared A minus 1. So all these identities are coming somewhere. It is things that have been proved. So now, if you look at your formula sheet on the exam, you will be given these identities. But now, these are not identities that came out of nowhere. These are what have been proved, and then you just can change this to this or that or any how you see fit to change those. Then also remember, you can change this back to your double angle. Remember, you can always move back and forth with identities. So the last thing that we have to look at now is a compound angle of a sine. So now if we have a sine of what? Sine of A plus a B, we know that if you're looking for a compound angle of sine, we are going to get sine cos and cos sine. So this means now what you're going to have is going to be what? A sine of A cos of B. But now, because you are dealing with sine, we always keep the sign the same. So this is going to be plus cos of A sine of B. So now, if you look at this last part here, you can write it as what? As sine of B cos of A, so that you can have that a similar relationship. But now you must make sure that if you use sine of A on this part here, on this side, you can't use the very same angle. You must use sine of the other angle. So the angles will differ like that. Okay, so now let's assume that we had the same angles. So if we had now sine of A plus sine of A, sine of A plus A. So this is going to change now and become what? We're going to have now sine of A cos of A plus cos of A sine of A. So like I said, remember now this thing is the same thing. You can just write it as what? Sine A cos B. So I'm just going to do that so that we can be able to add the like terms. So this is the same thing as what? As sine of A cos of A. So if you look at this, we are having now the like terms. So we can add them together, and therefore the double angle of sine is going to be what? 2 sine A cos A. So now if we had now a double angle of sine, we will normally know this is identical to the following. Let me just write this is number 4, identity that you should know. If you had now sine 2 theta, you can write it as what? As 2 sine theta cos theta. Remember that it is also an identity that it is proven. So all these identities, you should be able to memorize them, or you should be able to look them up on your formula sheet when you are answering or you are proving identities. So the second part, or the next part we're going to look at, is now what we talk about reduction, and we're also going to have just a bit of introduction on solving trigonometric equations. So remember now, when you talk about a reduction, we need to remember our quadrants. So now we have now 4 quadrants, which is quadrant 1, quadrant 2, quadrant 3, and quadrant number 4. So the angle here is 0 degrees. We have 90, 180, 270, and then 0 is the same thing as 360 degrees. So on our quadrants, we know that we have now what you call cast. So that means we have cast here. And then what does cast mean? It means now all the ratios on the first quadrant are positive. But now on the second quadrant, only sine ratio is positive. And on the third quadrant, only tangent is positive. And on the fourth quadrant, only cosine is positive. So this is what these four quadrants tell us. But now we know that in the first quadrant, we're going to have now the reference angle, which is now theta. So this theta, it must be a what? An acute angle, an angle that is less than 90 degrees. And then also, if you move in an anti-clockwise direction, that means you're going to get now theta as being a positive theta. But if you move in a clockwise direction, do you see now you're going to have now your theta as minus theta. So also on the fourth quadrant, you have minus theta. And then now, the part that we're going to use for reduction is to say now, on the second quadrant, we're going to have now 180 degrees minus theta. On the third, we had 180 plus theta. And then on the fourth, we also have 360 minus theta. And then now, we can also use what you call now the cofunctions, whereby on the first quadrant, we can represent it as what? As 90 degrees minus theta. And then this one is going to be 90 degrees plus theta. This is going to be 270 minus theta. And that's going to be 270 plus theta. Okay, so all these things that we have inside these quadrants are what will help us to do the reduction. So now let's say, for example, we were given the following to simplify. Let's say we have now cos of 180 minus theta, all divided by sin of, let's say now we have 90 minus theta. Can we now simplify the following? Okay, so now, how are we going to simplify the following? We're going to first have to try to reduce what we have at the top. So do you see now at the top we have cos 180 minus theta. So we must reduce it, for example, to maybe cos of theta alone. So how do we do that? We say now we first look at what we have inside, which is 180 minus. And then this 180 minus, it tells us which quadrant we should look at. So 180 minus is the second quadrant. And then on the second quadrant, it is only sine that is positive. So that means on the second quadrant, the cosine will be negative. So obviously the answer that we will get is a negative answer because cos is negative on the second quadrant. So after we have done that, then we can reduce this. This is now going to become what? Just negative cos of theta. Okay, so now at the bottom, we can also reduce, but now we should be careful if you are dealing with 90 degrees and 270 degrees. That is what we call now the cofunction. So the cofunction simply means now sine will change to cos and cos will change to sine. So if you look at this, we have 90 minus theta. 90 minus theta is the first quadrant. So on the first quadrant, everything is positive. So we don't have to worry about the sine. We know everything is positive. But now what we should worry about is that this thing inside here is 90 degrees. So that means this is going to change to its cofunction. So now that is going to be what? That is now going to be cos of theta. Because 90 makes sine to change to cos. And then cos to change to sine. Also the same thing with 270. So after we have done that, then we can simply simplify what we have because now cos theta and cos theta cancels out. And the answer to this problem is just going to be negative 1. So that is how we use those quadrants to determine or to do now the reduction. Okay, so now the last thing that we're going to talk about is now solving trigonometric equations. Let's say, for example, we had the following now. Sine of theta is equivalent to 1 over 2. I'm going to try and use my calculator. And my calculator, it is not a very nice calculator. So now what is happening is that when you solve for the angle in trigonometry, what you do is that you're going to say now we have the angle being equivalent to what? To sine of minus 1 over 2. So now, the answer that you get here is not the only solution. when you solve for the angle, you must note that that is what you call now your reference angle. So now the reference angle, you're just going to put in your calculator, shift sign, and then you put 1/2, and that will give you the angle of 30 degrees. So now 30 degrees is only what you call now your reference angle. It is not the solution. Okay, so now to get the solution or the general solution whereby you can put any value of theta here and you get half, you are going to do the followings. You're going to say now, okay, on this first part before you determine your reference angle, the ratio of sin, it was positive because you had no sign before that ratio. So that means you're going to look at the quadrants whereby sin is positive. So now you're going to say your solution is going to be on the first quadrant because sin is positive on the first quadrant, and it is also positive on the second quadrant. So we call this the general solution. So when you solve for trigonometric equations, you must always remember now you need to give the general solution. You don't only give one solution that you get. That is only the reference angle. It's not the only solution. Please bear that in mind. So now, for the first quadrant, we're just going to say, on the first quadrant, we're just going to say, okay, that means now our theta is what we have now inside the angle there. So theta is going to be equals to, on the first quadrant, we just have it now theta. You can just write the theta as it is to say now you have now 30 degrees, and then you say now plus k times 360. And then now k is an element of integers. So you should always apply the general solution when it actually comes to you solving this part of what you call now trigonometric equations. The other solution will be now on the second quadrant. And then on the second quadrant, first thing you look at what you have inside the ratio. So that is going to be what theta, you're going to say now theta is equals to, so this is 180. And then you minus your reference angle, because now your reference angle is theta, which is now 30 degrees. And then you're going to say now this is plus k times 360. And then you just simplify what you have there. So that means theta is what? 180 minus 30, that is going to give us 150 degrees. And therefore k times 360, it is what we call now the element, k is an element of integers. So now, if you add or subtract 360, you are going to get the same answer as half. For example, in your calculator, you can put now 30 plus 360. That is going to give you now 390. So now, sine of 390 is still going to give you half. If you also put k as a -1, for example, you're going to say now 30 minus 360, which is going to give you -330. So if you also put that, you will see now sine of -330, it is still half. So now you see now, if you only write this as your solution, that is not the only solution you have. You have all these mediana solutions. So when you solve for trigonometric equation, please remember you must give the general solution. So now with all this being said, then we can start to practice our trigonometry. So remember, we said now the first part that we looked at is a trigonometry of triangles. So feel free to pause the video and try to answer the question first before you look at how we do it. So now on the problem, they say now 2 sin of 24 degrees is equivalent to P, and then we must write down the following in terms of P. So the first thing that we must do, we must remember we are having this as a problem. 2 sine 24 degrees is equal to P. So that means now we can divide both sides by 2, and then we just have our ratio alone as a subject of formula, which means we have P over 2. So now if we have this and this is given to us, then we can represent this in a what? In a triangle. So remember, this we can represent it in which type of a triangle? A right angle triangle. So what do we know? We know that if we have now sin from SOHCAHTOA, it is always opposite over hypotenuse. But remember, for you to label other sides such as opposite and adjacent, you need the reference angle. So you're going to assume that our reference angle is this one here. We put the 24 there. So now, how do we now label this triangle of ours? We're going to say now, okay, the side that is looking at the angle will be the opposite side. So now what is the value of the opposite side? That is P. So you're going to put P there. And then now what is the value of the hypotenuse side? That is 2. Remember now, hypotenuse side is the one that is always looking at the angle of 90 degrees. So that means this value here is going to be 2. So we have used what is given to us to actually represent it in a triangle. So now this next step that is left is for us to actually fill out the triangle. For example, to find this part here and also to find the angle. So now we know that we can easily now find the angle. We can just say 90 minus 24 because we know all the angles inside the triangle are supplementary. So we'll see now, okay, this angle here is 66 degrees. Okay, so now how do we determine this other side here? If we assume this side is x. So we use the theorem of Pythagoras. We're going to say now this is r squared is equal x squared plus y squared. So remember r, it is always represented by the hypotenuse side. So we're going to say now we have 2 squared equals 2. So now we have x we're looking for. And then now y, we can write it as p squared. So now 2 to the power of 2 is the same thing as 4. If you transpose the p squared to the other side, we're going to have minus p squared. And this is going to be equivalent to x squared. So if you apply the square root on both sides, remember this is plus or minus, but because we are dealing with triangles, so we are dealing with lengths, this means now the solution will only be positive and square root of 4 minus p squared. And then now where we see this x here, we can just represent it as what? As 4 minus p squared. So now that we have fully defined our triangle, then we can start to answer the problems. So, but first you need to know how to define that triangle. So let us now try to answer the questions. So now the first question that we have, it says now we must determine sine of 240. So now we don't have this angle of 204, I'm sorry. So we're going to find ways in which now we're going to write 204 in a way that we can reduce it, but we must have either this as a reference angle or that as a reference angle because we have those in our what? In our right angle triangle. So now how can we write 204? We can write 204 as what? We can say sine 204 is the same thing as what? As 180 plus 24 degrees. So that is the same thing. This thing here is the same thing as 204. So after doing that, we can now use the reduction. Remember now, if we have 180 plus simply means third quadrant. And then on the third quadrant, how is sine? Sine is going to be negative. So now you're going to say, okay, the answer that you will get is going to be negative. But now this is going to reduce to now become a negative sine of 24 degrees. So we already have now the negative as part of the solution. So now when you solve now, remember now, when you talk about sine on our tool which is called Socator, sine, it is what we call now opposite over hypotenuse. So we are going to have negative opposite over hypotenuse from the reference triangle. But now look at this. You must be careful to look at what is our reference angle. The reference angle is this angle here. So now what is going to be the opposite side to the reference angle? The opposite side, it will be this angle of P there. So that means you're going to substitute to say now we have minus, the opposite side is P, and the hypotenuse side, remember, it is always looking at 90 degrees, so that is going to be 2 there. So that means now the solution to what we call now sine 204 in terms of P, it is going to be negative P over 2. So that is how we get the solution to that first problem. So now we can keep on going to answer now the second problem. On the second problem, they say now we must determine if we have sine of what? Of negative 66 degrees. So now remember now, if you look at our angles here, we don't have negative 66 as our reference angle. But on our quadrants, remember now, negative angle simply means what? Fourth quadrant. And then on the fourth quadrant, how is sine? Sine is negative. So that means now this thing, it can also be reduced and be written as what? As negative sine 66 degrees. So now we have reduced it. So then we can apply our triangle. So how can we apply our triangle? We're going to say now we have minus, and then we know sine. Sine is always opposite over hypotenuse. But now the reference angle is now 66. So now what is opposite the reference angle is going to be this side here. So we're going to say now we have now the opposite side is how much? A square root of 4 minus p squared. And our hypotenuse side is always opposite 90 degrees, and that is going to be 2 there. So that will be the solution to the second problem. So now if you look at the last problem, what do we have? On the last problem, what we have, they say now we must solve for if ever we have a cos of what? Cos of 21 degrees. So remember, like I said, you can determine a reduction, or you can also use what we call now in this case special angles. So we have special angles such as 30, 45, 60 degrees. So now the first thing that we will do now is to see now how can we write this 21, either having the special angles or having those angles that we can reduce with from the quadrants. Okay, so now I can see now, we can say now a cos of what? If you look at this, if we say now 45 degrees minus 24 degrees, that is still the same thing as 21. So 45 minus 24 is 21. That means we have not changed anything. Okay, so after we have done this, we need to now see, okay, so now we are having a compound angle. So if we have a compound angle, we need to use the compound angle of cos. Remember now it is cos, cos, but now we change the sign and then we have sine, sine. So we're now going to have what? A cos of 45 degrees, cos of 24. But now we change the sign. We're going to say now it's going to be plus. Then we have sine of 45 degrees. And then we have sine of 24 degrees. Okay, so I know that when you solve this problem, they will say now without the use of a calculator. So you just have to not show that you are using your calculator. So in this case, you're going to put in your calculator cos of 45 and you write it as a fraction. So if you put that in your calculator, you're going to get that cos of 45 is the same thing as square root of 2 over 2. But now, if you look at this, cos of 24, how can we get that? Okay, remember that 24 is the angle on our triangle. So we can just represent it in this case to say now cos it is always adjacent over hypotenuse. And then now if you look at the other side, we can say now sine of 45. Sine of 45 is still the same thing, which is now a square root of 2 over 2. But now remember, if you don't know those special angles, you can always just punch that part only in your calculator and place it in there. So now when we talk about sin of 24, we know that sin is what? Sin is always opposite over hypotenuse. So now we can simplify all this to get now the final answer. We'll say now we have now square root of 2 over 2. But now what is adjacent over hypotenuse? But we must look at what is the reference angle. So the reference angle is 24. So 24 is this part here. So what is the adjacent side? The adjacent side is this side. So you're going to have now, and that is what? Is 4 minus p squared. And all this is divided by the hypotenuse side, which is always opposite 90 degrees, and that is going to be 2. Then we keep on answering everything. So now we're going to have now the square root of 2, all divided by 2. But now what is the opposite of, if ever the reference angle is 24? So the opposite is just p then. So you're going to have p, and then the hypotenuse is just 2, so that is going to be 2. So that means now this is going to be our final solution. But now you need to just write it in a simplified way. So do you see now, if we just simplify this, we're going to say now the top will multiply with the top. So that means we have the square root of 2 multiplied with the square root of 4 like that. Okay. So if we have something like that, I'm just going to erase here at the top to create a space so that I can write them. So if you say square root of 2 multiplied by square root of 4 of that, so we can just put all of them in the square root and say now we have what? We have 2 multiplying with 4 minus p squared. Okay, because now if you have numbers in the both square root multiplying, we can just multiply what we have inside those square root. And then at the bottom, we can say 2 multiplied by 2, and 2 multiplied by 2, that is just going to lead us to give us 4. Then on this side here, we're just going to have now square root of 2 multiplying with p. That's going to be p square root of 2. And then we have now 2 divided by multiplied by 2. That's going to be 4. So now, if we see this now, we can just do what? We can just add the top part since our denominators are the same. So now at the top here, we can also simplify to say 2 multiplied by 4, 2 multiplied by negative p. So we're going to get now the square root of what? Of 8 minus 2p squared. And then now, remember that we have now the same denominator as 4. That means we can add now the top parts. So we're going to have now plus p square root of 2. Okay, so this will be the final answer to this last problem. So now, these problems, they can come in different levels like that. If you look at this last one, you had now to use the special angles. But if you look at this ones, you have to use now the reduction angles. And then this one here, you also have to remember now that reduction, but of a negative angle. So you need to practice and remember all those type of things. So the second activities that we're going to practice now, it is now what is called now proving identities. So now this is all the questions we're going to try to do and practice. So now you can feel free to take a picture of this or a screenshot of this, and then you can try them first before we continue, or you can just do this with me as we go like that. Okay, so now I have showed you all the problems that we're going to do in this video. So the first problem is whereby we have now to prove now if ever this identity is the same, whereby we have now sine of 2 theta being over cos theta. Then we have minus sine theta being equivalent to tangent theta multiplied by cos of theta. So now, when we prove identities, we first look at what? At the side that is not simplified. So if you look at this part here, we can still simplify it further, but now that this is not going to be very complex. But if you look at this side is not simplified. And then if we also look at the right-hand side, we only have one term. So this is a product. So now on this side, we have two terms. So the first step or the first approach that we need to do is to write all this thing as one term. That is the only way we can get the left-hand side to be equal to the right-hand side, if ever we have all this as one term. So now how can we write two numbers as one term? We need to add these two fractions. So how do we add fractions? Remember, let's say, for example, this is over 1 here. So what do? We can cross multiply. The first thing that we do, we just multiply the bottom part. We say cos multiplied by 1. So that means at the bottom, we're going to have now cos of theta. And what do? We say now we cross multiply. So that means now the 1 will multiply with the sine 2 theta. So that's going to be what? That's going to be sine 2 theta. And then now this part here will multiply with that part there. So we're going to get what? We keep the sign. This is minus. That's going to be sine theta cos of theta. So now we just cross multiply and we multiply the denominators so that we can add those two fractions. So, but now remember, when you start this, you're going to say, now I'm looking at the left-hand side so that you don't have to always write the equation, and because you are proving. Okay, so after you have done that, you will see now, okay, what do you have now? You have now everything simplified, but now you can also change this, since this is a what? Is a double angle. So if we change that double angle, we're going to get it as what? We're going to get this double angle of sine as what? As sine of theta, 2 sine of theta and cos of theta minus sine of theta cos of theta. So all this thing, if we do it like this, it will lead us to the answer. Okay, so but now we should always just look at the relationship of what we have to what we are looking for. Okay, so in this case, we have 2 sine theta cos theta minus sine theta cos theta. So these are like terms, so we can minus them out. So if you say 2 minus 1, that is going to be sine of theta cos of theta, all divided by cos of theta. So one person can decide to cancel this out here, to say now cos theta and cos theta will cancel out, and I'm only be left with what? With sine. And that is also one way you can look at it. But now you can just already solve this from here. To say now, on your right hand side, you have tangent of theta multiplied by cos of theta, of which if you look at this part here, you have sine theta over cos theta. So that is the same thing as tangent of theta. But now remember, now this thing here is the same thing as if you are having sine theta over cos of theta multiplied with cos of theta. Because if you were to multiply now this as fractions, you will say now top multiply with top, and then you will get this, and then bottom multiply bottom, and then you will get that. So that is still the very same thing. So now from here, you will see now this thing will just simplify to be what? A sine of theta over cos theta, that is a tangent of theta, and then you have now multiplied by cos of theta. So from here, we can clearly see now, okay, the left-hand side is equal to the right-hand side. So that means now we have proved that this identity is true. We say now the left-hand side is equal to the right-hand side. So remember, like I said, one person would have decided maybe to cancel this out here. To say now, okay, this cos and this cos will cancel out, and then now I'm going to be left with what? With only sine of theta. So that is still correct. So you have simplified the first side. Now you're going to go now to the other side. To say now on the other side, we have what? We have now the right-hand side. So on the right-hand side, I'm going to now change this tangent to an identity to say now this is the same thing as sine of theta over cos of theta multiplied by cos of theta. And then this will cancel that out. And therefore, you will see now you're going to get now your left-hand side as sine of theta, which is now equal to also your simplified left-hand side. So you can do it in that way also. So now, let us now look at the second identity. So like I said, remember, you can pause the video if you have taken the picture, or you can just wait for me to write this second identity where we have cos of x all divided by cos of x minus sine x. Then we have minus cos of x all over cos x plus sine x being equivalent to tangent to x. Okay, so we're going to follow the very same procedure to say now, what we have on this side, it is more simplified than this side. And what we see is that on this side, we only have one term. So on this side, we have two terms. We need to try and write these two terms as one term. So how do we do that? We're going to say now, okay, we're going to first do what? We are going to first multiply the denominator. So we're going to say this multiplied by that. So you're just going to write it as is that on our denominator. So we have what? Cos of x minus sine of x multiplying with cos of x plus sine of x. So after we have done that, what are we going to do? We're going to now cross multiply. We're going to say now this part here will multiply with that part. So we're going to have what? We're going to have cos of x multiplying with this bottom part here, which is cos x plus sine x. And then we keep the sign, which is minus. Then we're going to say this part will multiply with that. We cross multiply. So now the cos of x will multiply with cos x minus sine x. Okay, so but now remember, the most important thing, you should indicate that you are dealing with the left-hand side. So that is that. So now remember, now why do we add these things here? It's because we just want to have the one ratio, since we only have one ratio on the right-hand side. So after this first step, what do we do? Please get this advice. You don't have to always simplify at the bottom, but now you have to simplify at the top and see if ever there's something that cancels out with what we have in the bottom. So most of the time, you will see now there's something that you have at the top that will cancel out with something at the bottom. But if that is not the case, then you can simplify at the bottom. But please don't rush to simplify because you will have to work back and forth like that. So now what we are going to have is that, okay, at the top, we can simplify. So this will multiply with that will multiply with that. So we're going to have cos of theta, cos of x multiplying with the cos of x, and that's going to give us cos squared x. Cos of x multiplied by sine x, that's going to give us plus, and then I always like to start with sine. So this is sine of x, cos of x. So now we also have this other side here, negative cos of x multiplied with that part there, which is cos x, that's going to be negative cos squared x. Please be careful that you have to multiply with the whole negative. Then if you say now negative cos x multiplied with that part there, so that's going to be positive, but I always like to start with sine, so that's going to be sine x cos x. Okay, so we have simplified at the top. So at the bottom, we're just going to keep it as it is for now to just see if ever is there anything that we can factorize and cancel out. But if there is nothing, then we will simplify the bottom part. So now in this case, at the bottom, we still have a cos of x minus sine of x. Then we have cos of x plus sine of x. So if you look at the top now, what are we having? We are having now a cos squared x minusing with cos squared x. So that means they are going to cancel out. But we also can see now we are having these like terms that they are adding up, okay? So we're going to have sine x cos x adding with sine x cos x, and that's going to give us what? That's going to give us 2 sine x cos x. Okay, so remember now, we want to get this thing which is now called 2 tan x. So at the top, do you see now this is identical to what we call now sine 2x because that is a double angle. So that means at the bottom, we should also try to simplify and see if we can get a cos 2x. So now we have already seen now at the bottom, we have to simplify. So if you look at the bottom, what do we have? What I see here, what we have is a difference of 2 squares because you have cos x minus sine x, you have cos x plus that thing there. So if we simplify this, we're going to get the difference of 2 squares, whereby you're going to get cos squared x minus sine squared x. Okay, so now these two things that we have here, these are both identities. Remember now, this is an identity of what? Of what? Of a double angle of sin. So we can write it as what? We can say now this is the same thing as sin 2x. That is the very same thing. And then also, if you look at this is a double angle of cos. Remember now, we can write it as what? We can write this as cos 2x. So now from here, we can clearly see now, okay, this thing will just change to be what? To be tangent of 2x. So therefore, the left-hand side, it is now equivalent to the right-hand side. You can just put that, therefore, left-hand side is equal to the right-hand side. Because now we have what? We have now tangent of 2x, and we wanted to have tangent of 2x like that. Okay, so now we're going to move on now to the next identity. So on the next identity, what we have is the following. Let me just quickly erase here. And remember now, you can feel free to pause the video and try the problem before we work it together. So now the third identity we have now, cos 2x plus 1 over cos x. Then we have this being equivalent to 2 sine x over tangent x. Okay, so now this is what we have. So in this case now, what we are having is like both the sides are not actually straightforward for us. So we can see now we are having this as one term, and then also this as one term. So now we don't have to do that thing of adding. But now we need to look at the side that we can simplify, and then we see now what we get after that. Okay, so if we look at this side here, we can easily simplify this side. So I will prefer to start with the right-hand side, but remember now it's your preference. You can also start with the left-hand side. So in this case, I'm going to start with the right-hand side. try to simplify it and see now what direction should I take on the left-hand side. So now on the right-hand side, I'm having what? I'm having 2 sine of x, and then I can also change this to an identity, which is now what? Which is now a tangent can be written as what? Sine x over cos x. So now if I have something like this, if I have a fraction on the denominator, I know that this thing at the bottom will just multiply with what we have at the top there. Okay, so I can just simply write this like this. Let me just show you where that does that come from. Let's say, for example, you have 2 sine x, and then we divide it with what? With sine x over cos x, because this is what we have, divide. Okay, but now remember, now divide, we can change it to multiplication. So how do we do that? We're going to say we have sine x. If we change divide to multiplication, what we have is going to be cos of x over sine of x. So do you see now this part here at the bottom, it just automatically multiplies with the top part. You see now, it just moves from bottom to top there. So if you have something like this, you don't have to always work it out like this. You can just say, okay, this moves like that. Okay, so now if we apply that theory, you will see now, okay, on the right hand side, we're just going to have what? We're going to have 2 sine x cos x, and then all this is divided by sine x. This part here will remain at the denominator. And then now what do we get? This cancels out with that. So on the right hand side, we are having this thing simplified to 2 cos x. So now if we have the right hand side simplified, then we can start to look at what the left hand side simplifies to be. So we can say now on the left hand side, what do we have? We have now cos 2x, we have plus 1, we have cos x. So look at the answer that we have. The answer that we have is cos x. So if we have this double angle of a cos, we don't want to change it to anything that has sine, because if we change it to anything that has sine, that will actually get us to work more. But now we want to get straight to cos. So we're going to change this to an identity that is having cos. So remember now, the double angle of cos, we can also write it as what? As 2 cos squared x plus 1. Not plus 1, I mean that is going to be minus 1 from the identity. Please now remember that is minus 1. And then we also have now on this problem here, we have that part of plus 1. Then all this is divided by cos of x. So the reason why we change this to be a cos identity is because we are having the final answer as cos. We don't want anything to do with sine. You can change it to sine, but that is going to make you work more. Okay, so now after we have changed that, we can see now minus 1 and 1 will just cancel out. And then now on this part here, when we divide here, we can see now cos will cancel with one of the cos. And therefore, we're going to get now on the left-hand side, we have 2 cos of x. So therefore, now we can clearly see now the left-hand side is equal to the right-hand side. So now remember, there's many ways in how to kill a cat, but now just use a way that works for you. So this is done. Then we're going to look at the second problem, or the next problem. So on the next problem, what we have is cos x sine x plus sin squared x. I'm sorry about that. Tangent x being equivalent to tangent of x. Okay, so now this is what we have. So remember, we look at this side here. This right-hand side is almost simplified. I mean, it is already simplified, not almost. So that means now we should simplify what we have on this side. So we're going to look at what? We're going to look at what? At the left-hand side. So now on the left-hand side, we have 2 terms. And on this side, we only have 1 term. So now how can we add this thing to be 1 term? So remember now we must get a fraction. But now how can we get a fraction? We can get a fraction here. Remember now tangent can change to be what? Sine over cos. This is where we can get a fraction. So let us convert that to a fraction. So that means we have what? On the left-hand side, we are having cos x sine x. And then we can change that part there of tangent to be what? To be sine x over cos x. Okay, so after we have changed this, remember now, these things here at the top will just multiply, and then the bottom will also multiply. We have over 1 there. So this thing is the same thing as what? We have cos x sine x plus, if you say sine squared multiplied by sine x, that's going to give us sine cubed x, all divided by 1 multiplied by cos that's going to be cos x. Okay, so now remember now, the goal is only to have one thing on this side, because now we only have the solution as one thing. And then from there, we will see what we can do. So now how can we do this? How can we add this? Remember, this is over 1. The way that we can add these two fractions, we can multiply the denominators. So if we multiply the denominators, we're just going to get cos x. And then the next thing is for us to cross multiply. So this part will multiply with that, and this part will multiply with that. So we're going to get what? Cos multiplying with cos x sine x. That is going to give us what? That's going to give us cos squared x sine x. And then if you look at this part here, 1 will multiply with sine cubed, and that's going to be what? We keep the sign there, which is positive. Then we're going to get now sine cubed x. Okay, so now this is what we have on what? On the left-hand side. So now if this is what we have on the left-hand side, we want to get this on the right-hand side. But now how can we get that? If you look at the top here, we have now a common factor. And that common factor is what? Is sine of x. So we are going to take out sine of x as a common factor. So if we take it out as a common factor, we say now, okay, sine x is out as a common factor. Then we're going to be left with what? With cos squared x plus sine squared x. So look at this. Immediately, if we take now sine x as a common factor, this we get now another identity will just to make this whole thing there in the bracket to be equals to 1. Remember now, if we have cos squared plus sine squared, that is the same thing as 1. We can just write that as 1. Okay, because that is an identity. So now what is left is for us to have sine over cos. Sine over cos is the same thing as what? Sine over cos is the same thing as tangent of x. So now, do you see now on the left-hand side, we have now the same thing as on the right-hand side. Therefore, the identity is being proved. Okay, so at the end, everything will come to place. Just keep on applying the correct rules and try to see now how to make the left to be equal to the right. At the end, if you're applying the same or the correct rules, you will get to the correct answer. Please don't try to add things or create your own things. Always follow the rules. Okay, so now, let's say, for example, now we look at number E. Number E, we have what? We have sine of theta minus sine 2 theta, all divided by cos theta minus cos 2 theta minus 1 being equivalent to tangent of theta. So now, how can we solve this problem? The very same thing. We see now on this side, we have only tangent of theta. That means also on this side, we also have one thing. So now the only thing that we can do is that we know that the ratio of tangent, it is always sine over cos. So now at the top, we only have sine. But now if we change this thing, we're going to get a cos, because now this is a double angle, which is just going to lead us to a cos. Okay, so now let's just change that what we have at the top and see now what we can change the bottom part to. Okay, so now at the top we are having a sine. Let me just say this is left hand side. We have sine of theta, and we change this part here to what? To its identity. So that's going to be a double angle. So that is minus 2 sine of what? Sine of theta cos of theta. But now at the bottom, we also have this cos identity. But now what can we change the cos identity to? Should we change it to a sine identity? Should we change it to what? Like I said, remember, if you look at this, at the denominator, we are going to get cos, because tangent is what? Is sine over cos. So my approach is to change this to a cos identity. Someone would have done it a different way, but we will still get to the same answer. Okay, so now at the bottom, I will say now we have cos of theta, and then I change this identity to the identity of cos. Remember now we have minus, so that means you must put the bracket. So this is 2 cos squared theta minus 1, and then we still have what? Minus from the equation there. Okay, so now we can simplify at the bottom, but we can also see at the top there, we can take out a common factor. But let us first just simplify at the bottom. So now if we simplify at the bottom, at the top we still have sine theta minus 2 sine theta cos theta. So at the bottom, we're going to get what? We're going to get cos theta. Then we say this multiplied by that. That's going to be negative 2 cos squared theta. This by that, that's going to give us positive 1. And we still have minus 1. So automatically, this positive 1 and negative 1 will cancel out. So we know that, okay, if you say 1 minus 1, that is going to be 0. So now, you see now at the top, we can take out a common factor. And also at the bottom, we can take out a common factor. So now this is what we're going to do. At the top, you can see the common factor is sine of theta. So we take out sine of theta as a common factor. If we take it out, we're going to get what? 1 minus what? Minus 2 cos of theta. Then we also do the very same thing at the bottom. We take out cos as a common factor. So we take out cos as a common factor. And what we get is 1 minus 2 cos of theta. So do you see now this? It leads us to the answer automatically. Since now this part and this part will cancel out. And then if we have sine theta over cos theta, that will automatically give us what? It will automatically give us tangent of theta. And therefore, the left-hand side is equal now to the right-hand side. So that means we have proved that identity. So now, if we move now to, I think this is the last one, the last identity. And after the last identity, if you are patient enough, you will get a chance now to experience where we solve for trigonometric equations. So now, on this last part here, we are having the following. We have now a 1 plus tangent of x over 1 minus tangent of x being equivalent to 1 plus sine 2x over cos 2x. Okay, so now this one is a little bit tricky, but now if you look at it, on the left hand side, this thing is also not simplified, and then also on the right hand side, this thing is not simplified. So now it is really up to you which part you start with. So the part that I'm going to start with is this left hand side, because I don't like to deal with this tangent here. It's better if I'm dealing with sine and coses, so that I can easily get to whatever relationship I need to get to. So now I will say now on the left hand side, I will change these identities of tangent. So I'm going to have 1 plus, and then tangent, remember, is sine of what? Sine of x over cos of x. And then at the bottom, also going to have the same thing, 1 minus what? Sine of x over cos of x. Okay. So now on this side here, at the top, remember now I'm having 1 over 1. And also at the bottom, I'm having 1 over 1. So if I wanted to add these fractions at the top, what am I going to do? I'm going to say now, okay, the denominator is 1 multiplied by 1. By cos, I mean that's going to be cos x there. And then now what do? I multiply the denominators. Now I cross multiply. So it's going to be cos of x multiplied by 1. So at the top, I'm going to get what? I'm going to get cos of x. And I have plus. Then I will say 1 multiplied by sine of x. And that's going to give sine of x. Okay, so that I have simplified the top part there. Then also at the bottom, I will say now the denominators will multiply. So I will get now the cos of x. And then now I will do what? I will cross multiply. This will multiply with that. So that's going to be what? Cos of x. Then I keep the sign, that is minus. And then the 1 will multiply with that. That's going to be a sine of x. So now this is what I have now. Okay, so now this is starting to get to be something that is a little bit easier to simplify. Okay, but now remember now, if we have this as a division, we can write it as a normal division and then we change it to multiplication so that we see now what do we have. Okay, so now how do we do that? If we do that, we're going to have now the top part is cos of x plus sine of x all divided by cos of x. So this thing is divided by the whole thing, which is this part here. But now remember, if we change the division to multiplication, the bottom will come to top and the top will come to bottom. So I will automatically change this to multiplication. So if I change it to multiplication, I'm going to have what? Cos of x all being divided by cos x minus sine x. Okay, so after I've done that, I can clearly see now, okay, this and this will cancel out. And therefore, this thing is going to lead me to something like this, which I have now cos of x plus sine of x all divided by cos of x minus sine of x. So now I can clearly see now, okay, this thing is actually even more simplified. So now I will see now, if ever, what I have on the right, it can come to this part that I have here. So now what I'm going to do, I'm going to go to the right-hand side. So on the right-hand side, what do I have? I'm just going to erase this part here so that I create some space. So remember now, on the right-hand side, what do we have? We have this part here. This is still the same problem. Okay, so now we're going to move to say now, we are going to look now on the right-hand side. What are we going to look at? We say now, okay, on the right-hand side, we have that identity there. We can change it. So that is going to be the same thing as what? We're going to have 1 plus, that is the double angle of sine. So that is 2 sine x cos x. And then at the bottom, what do we have? We have now this double angle of what? Of a cos there. So now if we have a double angle of a cos, how can we change it? We can change it to sine and a cos because we have now on our final answer, we have cos and sine. So that means now the best way to change this identity at the bottom, it is to change it to have cos and sine. So that means it's going to be what? It's going to be a cos squared theta minus sine squared theta. Okay, so now this thing is not getting us what we have. So if you look at the left-hand side, we don't have 1 at the top. So that means 1 is an identity. So that means we can change it to a particular identity. So we're going to change 1 to an identity. Remember now the identity of 1 is what? Is cos squared theta. Let me just use x in this case. It's called cos squared x plus sine squared x. And then we have now plus 2 sine x cos x. Okay. So now at the bottom, we still have what? We still have a cos squared theta minus sine squared theta. Okay, so now what do I see? You need to be able to see this, okay? So at the top there, what you have, it can be factorized. And then also at the bottom, you have a difference of 2 squares so that it can be easily factorized. So now, but one thing that you need to see that is that, okay, you have cos squared, you have sine squared. Okay, so what you can do, you can just put this part here in the middle. Okay, let me just write it in a nice way. So I'm going to move this sine squared to the last part and move the 2 sine x cos x to this part, and then the sine squared I move it to this part. Okay, so at the top, what do I have? I have that part there that can be factorized. You need to know that this can be factorized. So how do you factorize that? Remember now, when you factorize a trinomial, you open 2 brackets. Okay, so now we're going to say now, how can we write cos squared x? We can write cos squared x by saying cos x multiplied with cos x. Okay, so now if you look at the factors of the last term, we just have 1 here. So now the factors of last term is just 1 and 1. But in any case, we know it is sine and sine. But we're just going to keep it normal so that we know how to factorize this. So now 1 and 1, if we add them, do they give us 2? Yes, they give us 2. So that means now this 1 here, you're going to write it as sine and sine, because now at the end you will want to get the sine squared. So you're going to have now sine x, and then you have sine x. So the last sign is positive. That means the signs must be the same, but we must take the sign of the middle term so that both of them there we're going to be positive. So if you would try to now simplify this out, you will see it will get you back to that part. You can try that on your own. So now, if we divide this at the denominator, we have now what is called a difference of two squares. So we can now factorize a difference of two squares by also opening two brackets. So remember now, difference of two squares, that's going to be cos of, this here, it has to be x. Please just try to write that as x. Please make sure everything that you write, it makes sense. So this is going to be cos x, sine x. This is going to be cos x, sine x. But now we know that this is a difference of two squares. One bracket will be positive and the other will be negative. So from here, we can clearly see now this top part can cancel out with the bottom part. And then now what we have left with on the right hand side is only what? Cos of x plus sine of x being divided by cos of x minus sine of x. And therefore this thing here, it will be the same as what we have done. So that means now the left hand side is equal to the right hand side. So that is how we would have proved that identity. Okay, so now the next part that we're going to be looking at, which is the last part, it is now how to solve for trigonometric ratios. And this is one of the most important part that you must also look at, because I know most students are struggling with this part here. Please feel free to take this the picture of what we have, and then you try to solve them first before we can go through them together. Okay, so now what do we have? The first problem that we have to solve for x. If now we had 4 sine squared alpha plus 3 cos alpha being equivalent to 4. And then now we are given a restriction to say now the alpha, it is an element that is in between negative 360 degrees and 360 degrees. So that means now we must solve for that there. Okay, so now how can we solve for that problem? Okay, so what do? We are solving for x. So when we solve for x, especially on trigonometry, what we want to do is we want to have one ratio on this one side. Okay, so now how can we have one ratio on this one side? The first thing that we see now, we have this as an identity. So now sine squared alpha, it can be written as what? As an identity of 1 minus cos alpha. So that is the first thing that we're going to do. We're going to change this to an identity of what? 1 minus cos squared alpha. Then we have what? We have plus 3 cos alpha equal 4. The reason why we change this to cos is because we want to have one ratio if possible. And then we want to see now if ever we can do what? We can get rid of everything, or we can factorize. It will last just as if like we are solving for x. But now we are solving for trig equations. So you should be more careful when you are solving these problems. So now what we're going to do, now we're going to say now 4 multiplied by 1, that is going to be 4. 4 multiplied by negative cos squared, that's going to be negative 4 cos squared alpha. Then we still have plus 3 cos alpha. So now if we move this 4 to the other side, that's going to be what? Negative 4. Then we have equal to 0. So automatically, what are we going to have? We're going to say now, okay, the 4 will minus out with that 4. So that means we have that there. So now in this case, for us to be able to solve for x here, we have to take out a common factor. Remember now, if you had now 2x squared plus x equals to 0, the only way to solve for x is to take out x as a common factor, and then you equate both the factors to 0, which is what we call the 0 factor law. So the very same thing you have to do here. So now we can take out what? We're going to take out cos as a common factor. So cos alpha is our common factor. And if we take that out, we're going to get what? We're going to get minus 4 cos of alpha plus 3. And this is equated to 0. So now we're going to get the first solution whereby we have now cos of alpha being equal to 0. And then now the second solution whereby we have minus 4 cos of alpha plus 3 being equal to 0. So now we can solve for this part here. We can transpose this to the other side, and then we divide by 4. So that means at the end we're going to get cos alpha is equivalent to negative 3 over negative 4, which will just lead us to positive 3 over 4. So now these are the two solutions that we have. I'm just going to erase this part here. I see now I need more space, and then this part we're not going to cover in this solution here. So now, what are we going to have now? We have now these two solutions. But now we are solving for alpha, we're not solving for cos. Like I said, if you are solving for the angle, remember you're going to get so many angles when you use what you call now your general solution. So now, what we have to get now is the reference angle. So to get the reference angle, we're going to say now the alpha is equivalent to second function of 0, and that will give us the reference angle and not the solution. So now the second function of cos of 0, let me just quickly punch this on my calculator. Cos of 0, that is giving me 90 degrees. So the reference angle there is 90 degrees. So now you see now this reference angle that we have is a special reference angle. So now also this thing is equated to 0. This means now you can't use your quadrants because now 0 is not positive, it is not negative. Okay, but now what you can use is to say now, okay, remember if I have a graph of what? Of a cos. A graph of cos is going to be a graph like this. Okay, and then now on your critical point, you see now if you substitute here on this problem here, if you substitute your alpha as 90, you will get now your cos as 0. Then if you also substitute now your alpha as 270, you will get now your cos as 0. So now these are the reference angles that where you will get now your cos as what? Your cos as 0. Okay, so that is what we know now from the reference angle. So now remember now this thing, it can continue to the positive infinity, and then it can also continue to the negative infinity. So the interval that was given in this problem, it is that alpha is an element in between negative 360 and positive 360. So this means now you must also continue with this graph here on the negative hand side. So that means now you're going to have the graph on that part there. So do you see now on this part here, you're going to have now this point here of negative 90 degrees and this point here of negative 270 degrees. So now all these critical points here are going to be the solutions to whereby your reference, your theta is being equated to that part there when we have the reference angle as 90 degrees. I'm not sure if this thing is explained correctly. Okay, so now we're going to say now, okay, the solutions to alpha of this first part here, all the solutions that are lying in this interval here, it is going to be whereby alpha is equivalent to negative 270 degrees, and then also alpha can be equal negative 90, alpha can be equal 90 degrees, and alpha can be equal 270 degrees. So all these are the solutions. It is not only one solution whereby the reference angle is 90 degrees there. So now, after you are done with the first part, remember you are not done. You have to also solve this other part. So these are the solutions. These are your other solutions. So now on this other part, what are you going to do? You're also going to do the very same thing. You're going to look for what? For the reference angle. So now what is your reference angle? You're going to say now, okay, my reference angle is whereby you're looking for alpha, and then you have now cos of second function 3/4. So now your reference angle is going to be how much? Remember, you must punch that on your calculator. And then if you say shift cos of what? 3/4, that is going to give you the angle of 41.41 degrees. So this is your reference angle. So like I said, this is part of your solutions based on the first part that we got. So now we're going to have now another solutions on this part. So now, but on this part, we will be able to use our quadrants because now this is not a critical angle such as 0 degrees. Now, if you have 3/4, we can clearly see now we can use our quadrant because now cos is positive where? So now we will say now cos is positive on what? On the first quadrant and on the fourth quadrant. So then we're going to get our solutions. To say now, the first solution is going to be what? Whereby alpha is being equivalent to what? Reference angle is what? 41.41 degrees. And then we can say now plus k times 360. And we know that k is an element of integers. So now, the second thing is that on the fourth quadrant, we also have now theta as what? We also have minus theta, alpha as minus alpha. So that means the other solution will be now minus 41.41 degrees. And then we can add now k times 360 degrees. And then the other solution will also be what? Remember now on the fourth quadrant, you still have what? 360 minus your reference angle, which is 41.41. Then you have plus k times 360 degrees. So now your alpha in this part is going to be what? If you now say 360 minus 41.41, you're going to get now your angle is equals to 318, and you have now 59, and therefore k times 360 degrees. So this is your general solutions. But now remember now they are generalizing. But on this question we were given a restriction to say now theta is an element, alpha is an element from what? From 360, negative 360 to positive 360 degrees. So we must only look at the angles that are in between that interval. Okay, so now do you see now from this first angle here, we will say now our angle here is equals to what? Is just equals to 1441 degrees, whereby now k is equals to 1. You're going to get another angle. To say now where k is equals to 1, that means you're going to add 360 to that. But do you see now if you add 360 to this, that is going to be more than your angles there. But now if you put now your k as negative 1, do you see now if you have now k as your negative 1, that's going to be 41.41, and then you have minus 360 degrees, because if k is negative 1, that is going to be minus there. So that means one of the solutions is going to be negative 318.59 degrees. Okay, so that is the solutions that you get from the first quadrant, and those solutions, they lie in this interval. So on this part here, the first solution is that one. So we're gonna say now, okay, we have now alpha is minus 41.41. Okay, so remember now, if you add now 360 here, you're going to get your alpha as what? As this part here, which is 318.59. Okay, but now, if you subtract 360 here, you will see now that is going to be beyond. That is going to be beyond our interval, which is more than negative 360. Less than negative 360. Then also on this part here, you can subtract the 360, but if you subtract the 360, you will get that part. So that means these are the part of your solutions on the second part, and these were the part of the solution on the first part. So all these are the solutions to your problem. Do you see now you don't only have one solution, you have so many solutions. And then you have to be able to determine all those solutions. So now let's say, for example, now we look at the second part. So on the second part, I'm just going to erase here because now I see this is going to be my last activity that we do, since this video is now becoming a very long video. Let's say, for example, now we have now a 2 sine alpha being equals to 5 sine 90 minus alpha. Is that okay? So now if we look at what we have here, what we have sine on this part, but now on this part here, we have something that can be reduced. So remember that we have a reduction, then we can apply a reduction. So the first thing that we will do, we will apply the reduction there. So we have now 2 sine of alpha, then we have 5 there. But now remember now this might change the sign, we don't know. We have to first apply the reduction. So where we have 90 minus is the first quadrant. And then on the first quadrant, all the functions are positive. So we know that the answer is just going to be positive. So we can write that 5 there. But now, because we are using a cofunction, remember now 90 or 27, those are the cofunctions. That means the sign will have to now change to be a cos of alpha. Okay, so now one thing that you should also know is that if you have a sine and a cos, you can make it to be identity. You are not canceling. When you divide both sides by cos of alpha, you are not getting rid of a cos. You are making an identity so that you are able to solve. So remember now, you can't divide by x if you are solving for x. Also here, you can't divide by a trig ratio if you are solving for trig ratios. But now in this case, if you divide by cos so that you can get a tangent, then that is not considered cancelling out the cos. So that means now you don't cancel it. You cancel it on this side, but now it has moved on this side. It is not cancelled. So on the side, we're going to have what? We're going to have 2 tangent of x being equals to 5. And then we can divide both sides by 2. And then we now have tangent of x being equals to 5 over 2. So now to solve this problem, we're going to do what? We're going to now get the reference angle. So the reference angle, when we get it, we're going to apply the second function of tangent, and then we have 5 over 2. So what will be the reference angle? Let me punch my calculator. We're going to shift tangent 5 over 2, and that is giving me the reference angle. That is 68.198. We can just say 68.20. So that is our reference angle. So now in this case, we don't have restrictions. So now we can just easily apply our general solution. So what are we going to do? We're going to say now we look at where we have applied the second function. So we're going to look at where tangent is positive. So remember now, tangent is positive where? Tangent is positive on the first quadrant and on the third quadrant. That is where tangent is positive. So now what we have inside here is just x. So we're going to say now x is equivalent to what? On the first quadrant, remember now we just have theta. So we're just going to say x is equivalent to the reference angle, which is 68.20 degrees. And then we say plus k times 360. And then we can just remember to say now k is an element of integers. Okay, so that will be the solution to the first quadrant. Remember now, this solution, it includes whereby k, it can be -1, it can be 0, it can be 1, it can be all integers. Okay, so now on the third quadrant, what do we know? We know that on the third quadrant, remember now this x here that we write here is coming from what is inside your ratio there. So now we're going to say now x is equals to what? On the third quadrant, we have now 180 plus the reference angle, which is 68.20. We can just leave it as 2. Then we add now k times 360. Okay, so now we must add this 180 plus 68. If we add those, we get the answer of 248.2, and then that is going to be plus k times 360. And then remember, don't forget to say now k is an element of integers. Okay, so now this will just be our solution. So this one is a little bit straightforward than when we have that restriction. Okay, so now the next problem that we have is the following question. Let me just quickly go to it. The next problem, it is when now we have 3 sine 2x minus 2 sine x being equal to 0. So remember, you can feel free to pause the video, try the problem yourself first before you look at how I do it. Okay, so now the first thing that we do, we can simplify here. This is a double angle, so we don't want the double angles. We can just simplify them. Since now this ratio here, it's not 2x, but if it was 2x there, we will add the like terms. Okay, but in the case we can't. So what do we have to do? We have to now change this thing to a double angle. So let me just change this. I'm using the red pen, so I don't know why I've changed to a white pen now. So I will get back to the red pen. So we have what, 3, and then we have what? This thing will change to be sine. No. Remember now, this is a double angle. So a double angle, when it changes, it becomes what? It's going to become 2 sine x cos x. Then we still have minus 2 sine x being equivalent to 0. So then we're going to say 3 multiplied by 2, that's going to be 6 sine x cos x, and then we have minus 2 sine x, which is equal to 0. So now when we solve here, we can just take out sine as a common factor, but we can take it as 2 sine x as a common factor, and then we're going to get 3 cos x, and then this is minus 1. All this is equal to 0. So if we are here, we can now apply what? We can now apply our zero factor law to say now this part here of 2 sine x is equal to 0, or this part here of 3 cos x minus 1 is equal to 0. So if we simplify on this side, we're going to get now this is 3 cos x. If we move the 1, that's going to be positive 1. You divide both sides by 3. Then we get that cos x is equal 1 over 3. So now we have two places whereby we have the solutions. Is this place here, if we divide by 2, we get sine of x is equal to 0. So remember now, we know if we get sine of x as 0, that is going to be our critical angles. Because now we can't say now sine is positive or negative whereby we have sine as 0. Okay, that does not make sense. So now how do we get those critical angles? The first thing that we must do, we must get the reference angle. So how do we get the reference angle? Remember now, the reference angle will be second function of what? Of 0 there. So now we're going to put that in our calculator. Second function of sine 0. And that is going to give us 0. So now the reference angle that we have is 0. So now if we have the reference angle as 0, so now the value of x, it can be equals to what? 0. We can add k times 360. And then k is an what? Is an element of integers. So now this will apply to all the critical values. But now remember now, if you're looking at sine, if you look at the graph of sine, let me just remind you, we start from here. Sine is 0 here, and then it's going to be 0 there at 180 also. Do you see now also at 180, we are having sine as 0. So that is a critical point. So the first part we are saying now where we have 0, we can add 360, we can subtract 360. All those solutions will be 0 there. But also this part of 180, it is also part of the solution. So we must also add it as what? As the solution. To say also whereby x is what? Is equals to 180 degrees, and then we add or minus 360 degrees. That will be the critical point also whereby we have now the reference angle as 0 there. I hope that makes sense. Okay, so now that is all the solutions that you get for the first part there. So now if we move on to the second part is a little bit easy because you don't need to remember the reference angle like plotting and all stuff. You just have to use your quadrants now. So the first thing that we do, we determine what? The reference angle. Remember now, to determine the reference angle, we're just going to say second function of what? 1 over 3. So now second function of cos 1 over 3, that will be equivalent to 70.53 degrees. So this is 70.53 degrees. So now if we have this as our reference angle, remember this is one of our solution, then we're going to move on to other solutions. Because now we have this reference angle, we're going to go back and look at this part here to say we're going to look at where cos is positive. So now cos is positive where? Cos is positive on what? On the first quadrant and on the fourth quadrant. So now on the first quadrant, remember we are just saving theta. So that means now we're just going to save x is equals to 70.53 degrees. And then we're just going to say k times 360. And then we know that k is an element of integers. But on the fourth quadrant, you can have both of them, or we can just have one solution to say now x is equal minus 70.53. Then you add now k times 360 degrees, and then k is an element of integers. That is, you can also give this one solution. This one solution, it has all the solutions whereby you also have 360 minus theta. It is included in this part. You get everything from that. Okay, so that will be how now you solve the second part. I hope this thing is starting to make sense, since many students struggle with this part of trigonometry. So now if we move on now to the next problem. On the next problem, we are having this is one of the challenge now. Let's see now how we can approach this. If we have 3 sine x cos x being equal to 1. Okay, so now how can we approach this? Remember now, our goal is only to have one ratio on one side of the equation. But if you look at this, we have now 3 sine x cos x. So this is a bit of like confusing. But now you don't have to get confused, because now you know that you have a double angle of what? Of sine, whereby you have now 2 sine x cos x. So now what you want to do is to write 3 as 2. How do you do that? Remember now you can say now 3 over 2 multiplied by 2. That is going to give you 3. That is the same thing as 3. I don't know if that makes sense. If you say 3 over 2 multiplied by 2, that means if you divide and multiply 3 by 2, you're still going to get 3. That's the same thing. So in simple ways, you can say now this is going to be the same thing as 3 over 2 multiplied by 2. You just write 3 as 3 over 2 multiplied by 2. You don't change anything, because this is still the same thing as 3. But the reason why we are writing it like that is so that we can have this double angle here. 2 sine x cos x being equal to 1. So we wanted to have this double angle. So now this coefficient here, it is not really that important for us, but what is important is to have that. Okay, so now you're going to say now, okay, you have now your coefficient, but now this double angle will change to be what? Will now change to be a sine of 2x. And then from here, do you see now this is easy now to solve. In this part here, it was kind of confusing, but if you know that you just have to write this as a double angle, then that is going to be easy for you. It is one of the things that you need to know. Okay, so now if you have done that, you can just multiply both sides by 2 over 3. Then if you multiply both sides with 2 over 3, you're going to see that this will cancel that. And then you just have now sine of 2x being equivalent to 2 over 3. So now when you are here, you also have to get what? The reference angle. So the reference angle, you always get it by using what? The second function of whatever that you have. So that is going to be second function of sine of that part there. So if we apply the second function of sine, 2 over 3, the angle that we get is equivalent to 41.81 degrees. So this is our reference angle. So now that we have our reference angle, we're going to look at what? At our quadrant. So we're going to look at where sine is positive. So now sine is positive on the first quadrant and on the second quadrant. So now what is important is that when you do this, you're going to put the angle that is inside the ratio there. So do you see now it is not now x. You're going to say now 2x is equals to, on the first quadrant, remember we just only have theta. So that's just going to be 41.81. And then you say this is plus k times 360 degrees. So now we are not looking for 2x. We are looking for x. So you can divide both sides by 2. So that means now the x is going to be what? It's going to be 41.81 divided by 2. That will give us 20.91. And then we have k. And then 360 divided by 2, that is going to be 180 degrees. And then don't forget to mention that k is an element of integers. So that is the solution that we get for the first quadrant. We don't have an interval here, so the solution just ends there. But now we also have another solution on the second quadrant, whereby we're going to say now we still start with what? With 2x. We have 2x, and then we have on the second quadrant, this is 180 minus the reference angle, which is now 41.81. 41.81, and then we have now plus k times 360 degrees. So now if we add these things together, we're going to get now 2x is equals to what? If we say now, let me just use my calculator, 180 minus 41.81, we get the answer as 138.19, and then we have plus k times 360. So we also have to divide both sides by 2. So now the value of x is going to be equals to what? The answer divided by 2, and that is going to give us 69.1. Okay, and then we have now plus k times 180 degrees, and then don't forget to mention that k is an element of integers. Okay, so this will be the solutions. So basically, when you solve for x on trigonometry, you have to solve for general solution. It's not only one particular solution you are looking for. Okay, so now we can move on. Now we have now two last questions that are left. So now the second last, we have now 12 sine 2x being equivalent to sine 2x plus 4 cos squared x. Okay, so now in this case, what do we have? If we look at what we have here, we have sine squared, we have cos squared, and then we have now this double angle. So now we're going to first change this double angle because we want all our ratios to have what? To just have x, not 2x. So we're going to get what? We're going to get 12 sine squared x being equals to, this is going to change to be 2 sine x cos x plus 4 cos squared x. So remember, like I said, you need to know that this can give you a quadratic. So now that means this trinomial will be able to factorize. So you need to know that. Okay. So now what do we have to do now? In this case, we can divide everything by 2 just to simplify it. So if we divide everything by 2, we can just say now, I will just say we have 6 sine squared x, and then we have 2 sine x cos x, and then we have now 2 cos squared x. Okay, so now when I solve the trinomial, factorize them, so I would like to start with the cos squared that is having like a prime number as a coefficient. That is going to be much easier for me to solve. Okay, so I'm going to transpose now this sign to the other side, but now I will say now this on the other side I'm going to be having 0, and then on this side I will start with the 2 cos squared x, since I like to work with prime numbers. Even if you started with 6 sine squared x, it's not a problem as long as you know how to factorize. So now if I this one here in the middle will be 2. No, that is going to be incorrect, because now the 2 will have to cancel out there. So that means this is no longer there. So we're just having what? Sine x cos x. And then if we move that to the other side, that is going to be negative 6 sine squared x. Okay, so now that is what we have. So from that part there, what can we do? We can now factorize. Remember now, when we factorize, what do? We open two brackets. So we say now, how can we write the first part here, which is cos squared? We can just write it as 2, and let me just erase them. We're going to write it as 2 cos x, and then we have cos x on the other side. Okay, so now if we look at this, we're going to look at the factors of the last term. So now we're going to look at the factors of 6. Remember, this is 1, 6, 3, and 2. But if we had this coefficient, one of the factors must multiply with 2. So now which factor we must multiply with 2, and then when we minus them, they give us the middle term. So do you see now this factor is the one that should multiply with 2, because if we multiply it with 2, then we're going to get what? We're going to get 4. So if we have 4 and 3, then these factors can minus and give us 1. So that means the factors that we're going to select is these factors here, 3 and 2. But now the factor of 2, it must multiply with this one of 2. So that means it must be on the other side of the bracket. So we're going to have 2 here, we're going to have 3 here. But now don't forget, you don't have to write 2 and 3, because this thing must give you what? 6 sine squared. So you must write it as what? As 2 here, but now it's going to be 2 sine x, and then this is going to be 3 sine x. And then from there, you're going to say, okay, this sign that I have here is negative. That means our signs are going to be different, but the bigger number will take the sign of the middle term. So the bigger number is what? Is 4. Is the one that is going to multiply with the 2 there. So in this case, this is the one that is going to be positive, and then this is going to be minus. Okay, so now that is what we have. And then from this part that we have, then we can try to solve for x now. How do we solve for x? We apply the zero factor law. We say now if we have 2 cos x minus 3 sine x being equivalent to 0, that is the first solution. Or if we have cos of x plus 2 sine x equals to 0, that will be other solution. So now we can transpose this to the other side. We're going to get 2 cos x equals to 3 sine x. Remember now, if we have sine and cos, we can just divide them, and so that they can give us a tangent. So now in this case, we're going to divide both sides by what? We're going to divide both sides by 3 cos x, 3 cos x, so that we're just going to be left with this tangent there. Okay, so now what is going to happen? This will cancel with that, this will cancel with that, and then we're going to get now 3 over 2 is equal to tangent, because sine over cos is a tangent. So we have now tangent of x being equal to 3 over 2. That is one solution that we have. And then on this solution, we can transpose that to the other side. So we're going to have now 2 sine x equals to negative cos x. And then what we can do the very same thing. We can divide both sides by 2 cos x to cos x. So now what are we going to have? Now we're going to say now this will cancel with that, and this will cancel with that. So we're going to have sine over cos, which will give us a what? A tangent of x being equals to negative 1 over 2. So these are a part of the solutions that we have. But now remember, from these two solutions that we have, we need to find the general solutions. So the first thing that we do, we get now the reference angle. So remember now the reference angle is going to be tangent a second function of what? Of 3 over 2. So that means the reference angle here will be equivalent to what? I'm using a calculator from my phone, and this is kind of challenging. Please just be patient with me. So we have second function of tangent, 3 over 2, and that is going to give us 56.31 degrees. So that is the reference angle. And then now what do we have to do? We have to look at the quadrants where the solution lies. So now tangent, it is positive where? It is positive on the first quadrant and on the third quadrant. That is where our solution is going to lie. It's going to lie on the first and on the third quadrant. So now we're going to say now on the first quadrant, what do we have? On the first quadrant, what we have is what? We're going to write what we have inside the function, that is x. So we have now the reference angle as it is, which is now 56.31 degrees, and then we just say k times 360, and then we know that k is an element of integers. So that is going to be the solution on the first quadrant. And then now on the third quadrant, remember now on the third quadrant, what we have is 180 plus the reference angle. So now this is going to be my plus with what? With k times 360. Okay, so now the value of x is going to be what? If we punch this on our calculator, 180 plus 56.31, 56.31, and that's going to give us a 236.31, and then plus k times 360 degrees. So now don't forget to mention that k is an element of integers. Okay, so now you are not done, because now you also have to find the solution to that other part. So you have to include everything. So if we now want to find the solution to the other part, how do we do that? We're going to apply now the very same thing to say now we're going to look for what? For the reference angle. So you're going to look for the reference angle where we have tangent of what? You don't have to put the sign there. You can say tangent of 1/2. You just look for the reference angle. Remember, this sign here, it only tells us which quadrants we should look at. So now if you look at the second function of tangent 1/2, that is going to give us a 26.57. Okay, so now that we have the reference angle, then we can put in our quadrants to say now, if you look at this, tangent is negative where? Tangent is negative where? On the second quadrant and on the fourth quadrant. So that is where the solution lies, okay? Yes, and I've been writing a lot on this document of mine, so my system is starting to become slow, but we are almost done now. Okay, so now we can say now on what? On the second quadrant, remember on the second quadrant we have what? We have 180 minus. So that is going to be 180 minus 26.57 degrees. So if we just put that in our calculator, 180 minus 26.57, that is going to give us x is equivalent to 153.43. But now don't forget to say plus k times 360, and then k is an element of integers. The very same thing you do for the fourth quadrant. On the fourth quadrant, remember now you can just have now your minus angle. So you can just say minus 26.57, and then you just say now plus k times 360, and then now k is an element of integers. Don't forget to mention that. K is an element of integers. So all this will be your solutions to this problem. So many solutions. But remember now, in the exam, you are only going to be asked one question. We are doing this many problems so that you can have an idea of how to approach this in the exam. So now we have now the last question to look at, the last of the last. Okay, so now the last question that we have, it is whereby we have now a sine 2x being equivalent to tangent of x. So now how do we solve this? So now we can solve this by doing what? By seeing now this is an identity, we can change it, and that when we change it, that's going to be 2 sine x cos x, and then also a tangent is an identity, so we can change it, that's going to be sine x over cos x. So now what can we do? We can just transpose this to the other side, and then see if we can take out a common factor, or we can cross multiply and take out a common factor. It is really up to you how do you do it. Okay, so in this case, I see now if we cross multiply, this might be very easy for us. So let's cross multiply. So if we cross multiply, we're going to get what? We're going to get 2 sine x cos squared x, and then we're just going to have this cross multiplied. That's going to give us sine x. So now we can transpose this to the other side. Remember, you don't divide. If you divide, you are getting rid of other solutions. So you transpose it to the other side. We have what? We have 2 sine x cos squared x minus sine x being equivalent to 0. So now in this case, we can take out the common factor as what? As sine x. So if we take out sine x as a common factor, what we're going to get is 2 cos squared x minus 1 being equivalent to 0. So that means you're going to get the solutions whereby we have sine x being equals to 0, or where we have what? Where we have 2 cos squared x minus 1 being equivalent to 0. Okay, so now what are we gonna do now? So let's simplify this part here. If we simplify this part, we're gonna transpose this to the other side. So that's gonna be 2 cos squared x equal 1, and then we divide both sides by 2. We get now cos squared x is equals to 1 over 2. So remember now, if you apply the square root, the answer that you get is plus or minus. So that means now you are now going to have 3 solutions. Remember now, the first solution is whereby we have sine x equal to 0. So the second solution, it will be where we have cos x being equals to positive square root of 1 over 2. And then the last solution, it will be where we have cos of x, whereby now this is equals to negative 1 over 2. So you have now 3 parts of the solutions. This squared here, it simply means you have to when you apply the square root, you put the plus or minus and include all those solutions. So now how do we solve all these solutions? We're going to start first with this one of the critical values. So if we start with the first one of the critical values, remember now we're going to say now what is going to be the reference angle. The reference angle is just going to be the second function of sine 0. And then we get the reference angle as how much? I forgot about that. Let me just do it on the calculator. Second function of 0, that is 0. So that means now we get the reference angle as 0. Okay, so remember now on the reference angle here, it is very much important for you to draw your graph so that you see where your solution lies. So if we have now a graph of sin, it starts from 0 like that. So do you see now we have the critical point at 0, and then we have the critical point as 180. So now this is going to be 360 there. So now that means your solution will lie in between, let's say for example, it is where now your x is going to be a solution where you have now 0 plus k times 360 degrees, and then now k is an element of integers. Remember now, if you put the 0 here, it also includes the 360, because now if you say k is 1, 360 is going to be part of the solution. But now you also have to put in now where x is 180. That is also a critical point. So now you're going to say now x, my system is very slow, x is equal to 180, and then you say plus k times 360. And then k is an element of integers. Okay, so that is how you solve the part for critical values. So now you have to solve this part, and you also have to solve that part. So now, if we come to this part here, we're going to see now we have cos. So cos is positive where? Cos is positive on the first, and it's also positive on the fourth. So you're going to write your quadrant. This is first quadrant. This is fourth quadrant. So now on the first quadrant, what do you need? You need now your reference angle. So now that means for you to get your reference angle, you're going to say that, okay, the reference angle is going to be now the second function of cos of what? Of the square root of 1 over 2. Remember now, this reference angle will be the same for this one. You don't have to look at the sine, you just have to look at the reference angle. The sine only gives us what? The quadrant. So now if you say now second function of cos square root of 1 over 2, then we are going to get now the reference angle is 45 degrees. So we get the reference angle as 45 degrees. My system is very slow, and I'm glad that we're about to get done. So that is 45 degrees. Okay, so now on the first quadrant, you're just gonna say now x is equals to 45 degrees, and then you're gonna do what? Plus k times 360. K is an element of integers. You just do that. And then also on the fourth quadrant, remember now on the fourth quadrant, you can just put now this is minus 45 degrees. Then you say now plus k times 360, and then k is an element of integers. So now you don't have to forget this last part here. The last part here, it is whereby where cos is negative. So also you have to include those quadrants. So that means now you're going to have now the second quadrant and the third quadrant. So now how do you do that as a solution? You're going to say now x is equals to what on the second quadrant? That is going to be 180 minus 45. So now if you say 180 minus 45, that is going to give you 135, and then you have to put in that 3k plus plus k times 360. K is an element of integers, and then now on on quadrant number 3, remember now this is 180 plus. So on 180 plus 45, that is going to give us how much? That is going to give us, let me just I forgot how much that is. So that is going to be 225. So we get 225 degrees. So you're going to say now 225